Okay, good afternoon, everyone. Welcome to our class. So today we will have a special lecture, okay, for our special guest. So I just introduced the speaker. So the speaker's name is Dr. Hafiz Basaruddin. He's an assistant professor from Lee Kong Chian Faculty of Engineering and Science, Utah University, uh, Tunku Abdul Rahman, Utah Sungai Low Campus. So his expertise is in communication, meteorological, MATLAB, okay, and also uh, electromagnetic wave. So our title for talk today is training on reading, analyzing, and display meteorological using MATLAB. So I hope all students can prepare your uh, question, okay, and jot your notes for your assignment later. Okay, so I will give the question after this class for assignment for talk today and for last week talk. Okay, and I also will share the video lah. Okay, in case you uh, forgot the points. Okay, but video for today I think will be available later. Okay, so without further ado, I would like to invite Dr. Hafiz Basaruddin to deliver his special lecture. So please welcome.
Hello all, I'm Dr. Hafiz and thank you to Dr. Azlan. He's my former colleague when we were working at Unical. Now we went separate ways. He's at the UTM and I'm at Utah. So thank you all for having me today for the for the special sessions as mentioned by Dr. Azlan, which is to basically read how to read, analyze, and display data using MATLAB. Especially the data that we're going to talk about is the meteorological or hydrology data. And the thing is, you can actually use any other software if you wish to. I mean, MATLAB is one of the examples that you can use to play around with data. You could use Python. Oh, okay, Q&A open. You can use Python. You can use any other program, C language, C++. The most famous would be Python and MATLAB, I believe. Other than that, probably C++. So you can use all this programming language to basically read the data. If you master one programming language, basically it's easier for you to learn the other languages. Or you can use MATLAB, for example, and let's say you want to play around with Python, then you can use your best friend currently, ChatGPT, to help convert MATLAB code to Python or vice versa. There will be some minor errors, but it will be no problem for you to fix. For now, for today's session, I'm just going to show you using MATLAB on how to read the data. And then after that, you can play around either using MATLAB or using Python, should you wish to. Okay, so without further ado, I think I would like to share the presentation slides. Okay, entire screen, allow. Okay, right, so I hope everyone can see my slides here. Let me know if there's a problems in displaying the slides. Okay. So there we go. So can you all see the slide, yeah? If I change the slides?
Yes, sir. Visible.
Yes, doctor.
Okay. Thank you so much. All right. So this is the slides that I'm going to share with you all. I believe I can share the slides later on to Dr. Azlan so that you can have a look in greater details. So let's have a look. So today we're primarily trying to tackle two things, which is how to use MATLAB to read and analyze the data, and the second thing is the data will be on meteorology. The reason why I want to touch on meteorology because so many research currently, even at the undergraduate levels for your, let's say, IDP or for your final year project, if it is involved meteorology, for example, rain, clouds, temperatures, climate change, everything, you can use this data here. And the best thing about this data is that it's basically free and widely available. So let's have a look first. When we talk about the meteorology, it means the weather in our atmosphere, particularly the contains of the water molecules, water vapors in the form of clouds, rains, or tornadoes, something like this, with extreme pressures, wind, and water uh, in our atmosphere. So this is basically meteorology. So you can have all sorts of data actually from meteorology in the form of rain, cloud, snow, and fog. Depends on what kind of research you want to do. So after this, I'll show to you the one examples of the current research that I'm doing. And if you want to go to the different branch of research while using the meteorology, same meteorology data, that is also fine. Okay, so here is the applications from having the meteorological data. So you can do a lots of stuff. You can do, for example, the climate change study. When you observe, let's say, the change of temperature, pressures, rain, or anything. So, for example, like this graph here, okay? You can also use it for agriculture. Let's say if your research or your projects dealing with the agriculture where the rain, for example, or temperature, soil moisture is very, very important, all this data. Okay, the other one is, of course, this is the famous one, disaster management. So with data, especially, let's say, we talk about the flood or landslide, one of the crucial parameter is rain. So with the rain data, then you can sort of like analyze and perhaps predict which area will be prone to a flood or landslide next. Okay, now strangely enough, meteorology can also be used in telecommunications. So, can anyone guess how the meteorology, the climate change, everything affects telecommunication as well? Anyone has a clue? The
Does like
ah,
does cloudy
pardon?
lightning storm affect the does the cloudy lightning storm affect the the signal transmission?
Yes, correct. Exactly. That's it. You're right. 100%. So the extreme thunderstorms or extreme rain events, for example, let's say if you have a very, very heavy rain events, it can disturb the wireless transmission, especially those who rely on satellite communication. One such example, if any of you still have what's that service called Astro, if your Astro is still using satellite dish during the raining events, you'll notice that the signal becomes distorted to the point where it's just blank screen and there's a small wording down, I think at the lower left or lower right of the screen showing, we apologize for the technical issues facing with our equipment. This phenomena is known as rain fade or something like that. So it's because of rain, more losses for the radio signal. Okay, so that's one good example, like what you mentioned just now, how the extreme weather can affect wireless transmission. So that's why now in the telecommunication fields, people are now beginning, people, engineers are now exploring more and more about this because it used to be a two disconnect fields, one in meteorology or geology or hydrology, another one in engineering. So these two groups, they don't usually communicate each other. But now with the increasing demand for 5G or for 6G, for higher frequencies, higher bandwidth, and at the same time we have problems with the climate change, so now the two sides begin to start, you know, communicating and collaborating. It's still early, but we're on the right track. So that's about the application in telecommunications. Okay. Now, another one is weather forecasting. Of course, if you want to go on fishing, so you rely on the weather forecast, forecast news. So this is one of the crucial, well, one of the famous applications. Another one, aviation. Okay, correct. Especially for the smaller planes where all those big clouds, thunderstorm is very, very important for them to avoid. And any others application that you can think of that rely on meteorological data. So just imagine with all this, different fields, different application you can apply if you have the meteorological data. Okay, and the good thing about this is that it's where is it supposed to be? Later on I'll show to you. It's publicly available and it's free. Okay, so how do they measure these weathers here? I mean, for example, the rain events or temperatures or pressures or wind. So they have lots of ways on how they measure. They use the weather stations, for example, like this. Okay, the cheapest one, and then they have weather balloons if they want to measure the weathers or atmosphere at different heights or different levels. Okay, and then we have the weather satellites, the most expensive, but at least it offers global coverage. Okay, so these are the three ways. There are more ways. You even have the very rudimentary equipment to measure waste. For example, they call it rain gauge. You just have the I think something like a container with a ruler to measure the rain accumulation. That is also one way to measure. Okay, so in some products, they actually use three of them. They combine to kind of like make it better, the predictions for weather. Okay, so this is one of the examples where you have meteorological agencies throughout the globe that provides meteorological data. Usually, each nation they have their own what do you call it meteorological departments that provide such data. So, for example, in Malaysia, we have Met Malaysia that provide rain data, cloud, temperatures, pressures. Uh, I believe in Met Malaysia you have to pay. Can't remember if you want to have a rain for about 1 year, a data about rain only, you have to pay about I think 1,000 ringgits or more. So that's Met Malaysia. And then you have NOAA here, NOAA. This is under National Administration and Space Agency, NASA. This is from the United States. And then here you have Met Office from UK. Now, Met Office, they offer their data for free as long as you do it for research, not for commercialization purposes. That's Met Office. And their data is pretty good, pretty precise, pretty reliable. And then you have this one, NOAA. NOAA, I think, is probably the best because they offer free data. Doesn't matter whether you're students, your industry, your business, or you want to do some other stuff for your YouTube channel, for example, you can use NOAA for free. So I think they approve laws in the United States that all this data from NASA should be free uh, and uh, and publicly available throughout the globe. So even if you're outsiders, you're foreigners, you can still download the data for free. So I'll show to you after this about NOAA, where to get the data from. Okay, so this is the example of the data from Met Malaysia that I choose. So for example, only one station at Petaling Jaya. So and then they produce this data here. I think this is for 1 day data. Every hours until 24 hours here. So you can see every hours. If you have rain, then how long was it? For example, 20 minutes, and then how much is it? Okay, so this is the data in terms of rain in Malaysia. Okay, but for this session, we'll focus on the data from NOAA because it's free. It's publicly available. You can just download it right now if you want to, and to do anything you want. Maybe if you have some ideas for your final year project, let's say you want to focus on plantations, you want to create a IoT device that can measure this and that, and then this IoT device can also be compared with meteorological data, then you can use this data if you want to. So it's free and it's global, so it covers everywhere, including here. Let's say if you're a foreign student, you already graduated, and then you want to serve your country, or you want to go to or some other places, you can always carry this data and then use it there because it's global. So this is how the data from NOAA looks like. NOAA has lots of data, okay, and each data have its own parameters. For example, what do you want to look at? Rain only, temperature, pressures, water vapors, oxygen level. So they have all that. So you can pick and choose whichever you want and download it for free. So for now, we will focus mainly here. They call it NCEP, NCAR reanalysis data. I can't remember what this word stands for, but I do know the reanalysis means that if you remember that I showed to you the weather satellites, weather station, so they gather the data from all of these instruments and then they combine it together, they blend it, and then they improve it using their own models, AI models or something, to make it better, more accurate. So that's why they call it reanalysis. And they have the data all the way from 1940s and 1950s globally. So if you want to do in terms of climate change study, you can choose this data. Okay, and so they have 17 different pressure levels or layers. So they have 17 layers, start all the way from the surface. If you want to measure anything in our atmosphere at the surface level, all the way to the I think to the ionosphere, or at very top of our atmosphere, so way kilometers high, and it is at the global scale. So this is NCEP, NCR reanalysis data. I believe I already have two students, no, three. Two undergraduate FYP students already completed their studies and degree using this data, and another one, currently PhD student, is also using this data for her research. So this is one of them. Another one is called hydro estimator. Now, this is just the for your information if you want to have a look. It is quite similar with this. It's as such, it is also global data, so on and so forth, but it contains only rains, because this one is specialized for rains only. So if you're into let's say if you want to focus more on flood risk analysis, or agriculture, maybe you can use hydro estimator. However, this data also have about rain, but not as detailed as this one. Okay, so it's up to you which data that you want to have a look at. These two are very similar, okay, and both under NOAA. Okay, so I put the links here. If you want to go to this website to extract the data, they will show to you everything on how to read the data, especially this one. They give you even some examples to use, let's say, to use Python to read the data. So after this, I'll share with you about the how to use MATLAB to read all of this data. Okay, so now for my research that I've been using this data is that I use the data from the NCEP, NCAR reanalysis data to basically calculate what they call it rain height here. Now this is, if you remember when I talked about the applications here, under the telecommunications here. So this is my area of research currently. So I use the data from NCEP, NCR to basically determine the rain height, the height of our rain events, which is actually crucial for satellite communications. Here is the reason why rain height is important. So let's say you have the satellite dish here and you have the antenna here. Now, beyond or above the clouds, your signal is fine because you have no rains or whatsoever to distort your signal. It's basically free space for your signal to travel. Okay. However, between the clouds here, at the base of the clouds, all the way to your satellite dish here, this is the problem part. So even though here could be only few kilometers, the height here, but it is more than enough to damage or to distort your signal to the point where you might experience what they call it outage, a complete loss of signal. That's what happened for those who subscribed to Astro previously using satellite dish. So that can be a problem if your network rely too much on satellites. Okay, so this is rain height, and so the height of the rain can play a vital role to determine the strength of your signal. So what do you think if I increase my rain height here? Let's say if the rain height increase, will my signal experience more losses or less losses? What do you think? To put it in a simpler words, if my rain height increase, would it be worse or better or neutral? Nothing going to change. Okay. What technology? Oh, okay. Oh, that's the question. Oh, there are plenty of questions. Okay, so, I'll read one by one. Yeah. Final year project. This one I'll answer later on after my presentation session. How can real-time meteorological and hydrological data used to prevent disaster and protect communities effectively? So this one, basically, when you have the data, you can actually sort of like create a prediction which area going to be affected next. So you can have the preparations in terms of the what do you call it, the rescue services, I believe, from the firefighters or paramedics to stand by, or something like if you want to, let's say, plan a development. So this area shows a very highly concentrated with water or rain events that can cause landslide and flood. So do not build in this area, for example. So you can use the data here to prevent such disasters. Although whether the authorities would like to follow your advice after presenting the data, that's another story. But at least you do your research and you present the data. So that's the usefulness of the data. In terms of the real-time data, you can basically monitor it, the data. Oh yeah, by the way, all the data here is close to real time too. It's very close to real time, so you can monitor right now what's going on in that location. For example, is it wet? Is it dry? Or will it prone to a disaster later on? So you can perform lots of stuff as long as you have the data. Okay. What new data sources or techniques are emerging in meteorological research? What new data sources? I would say currently probably satellite are the most advanced of all, because previously we use a lot of small equipments that we placed on the surface. So like for example, just now you see the pictures, a small weather station. But the problem with the weather station is that it only covers a small area, whereas satellite, it can cover globally. Unfortunately, in terms of accuracy, satellite may not be that accurate as compared to weather station, because the weather station you measure directly, whereas satellite you have to view it from the top. But with the advancements of AI modelings and more integration with the other sensors, so now they're able to kind of like they improve the satellites. At the same time, they use the data from the satellite to compare with the weather station. So is it accurate? If it is accurate, good to go. So the satellite is still working, for example. Okay, so that's I think the emerging in meteorological research in terms of data, how they acquire it. Okay, how is weather balloon's position is control for its operation? This one, yeah, it is uncontrolled movement and it has some risk actually. When you put the weather balloons, when you let it go and that's it, you basically just you let it go and you pray. let the wind carry it forward to whichever places it wants to go. Although technically it has the trajectory, they actually they have the so-called wind trajectory from the map, which you can get from the data as well. That can show to you, okay, this is the current wind trajectory path. If you let go of the weather balloon right now, so your weather balloon will end up at this location, that location, and that's one technique on how they want to release the weather balloon safely, and also able to predict where the weather balloon is going to land next. Okay. Which method is most accurate to measure meteorological or hydrometer? The weather station. The if you have the let's say a holder, and then after you have a ruler to measure the height of the accumulated rain, that is actually a lot accurate because you measure it directly without using any electronics equipment or sensors to detect it. You measure it yourself. Of course, the only downside is that it's not automated, so you have to stand there, wait for maybe 10, 20, 30 years to collect data enough for the climate change. So you can't do it. So you have to use machines to do the automation for you, all the sensors. But with that, it comes at a cost of accuracy. So that's the kind of like the pro and cons. So the most accurate method, that one, the one I mentioned, the on the weather stations, all those rain gauges. It looks simple, the equipment, but it's actually very accurate because it measures directly. Although, if you want to move uh, beyond, or you want to cover a broader subject, broader topics, better to use satellite because it's free and it's global coverage. So you can analyze not just in here Malaysia, but any regions you want to, basically, or any un, un, uninhabited regions, for example, like the tundra or desert area. So you can do so. Okay. What technological advancement could improve the accuracy and accessibility of meteorological data? I think this is the what I mentioned previously. So recently they deploy a lots of, let's say, AI modeling to blend in all these different sensors to make it more accurate. So that's one of the advancement they did. Actually, they already did it in the past, but with the advancement of AI modeling, so now it's accelerate the process, and the advancement now accelerate to be better and better and better in terms of the weather predictions or the weather accuracy. What is the materials of the meteorological balloon? It can actually. I can't remember. I'm not sure what's the material. It's not the standard typical balloon that pops out in the atmosphere, but I'm pretty sure it's one that can stand the low pressure up there, and also extreme temperature because it's quite cold up there. So any materials that can stand these two, that's perfect for the weather balloons. Okay, so next question. Do you have any idea how the current and future jobs market in this study? How the current and future jobs market. Okay, so this one, I mean, of course, not just the weather forecaster, but actually, let's say if you want to move to a data scientist, for example. So this is a very, very good input if you have a project as a data scientist that dealing with weather, which is currently what the people at the, I think, telco companies. One of them, Celcom DG, another one, Digital National Berhad, DNB, because they're doing the research on how the weather affects telecommunication infrastructure, because they don't want their base stations flooded with water or have too much rain. So they rely on this data, weather data here. So they have the data scientists that use this data to analyze it. And those data scientists, I believe, they are paid about 5 figures, 10K, I think. Some 8, some 9K. The one that I met about 10 or 11K. So, and they're quite young. So that's good for you, I guess. Okay, one more question. How do you handle the data from different sources with varied resolution and accuracy? That's a very good questions. The each data, they have their own, what they call it, resolution. So when you want to analyze the data, you have to understand first what's the data made of, what's the format of the data. And usually they will tell you from the website, it will tell you what's the resolutions. If they don't tell you, then you can find it in using MATLAB or Python, which I'm going to show after this. Okay, so hopefully we can, that's the question that we already covered. So I'll show to you about my, what do you call it, the example of my research, and then into the MATLAB on how to read the data. We'll start slowly, one by one, until you understand how to use the MATLAB to read the data. Okay, so this is the rain height I've been talking about. So basically, my research is to measure the to determine the rain height using the data from NCEP, NCAR. Basically, I need two kinds of data: the temperature and the height. As long as I have these two, number 1 and number 5, I can determine my rain height. Now, for others, if you want to go for the a different research, you might need, let's say, wind vector. Let's say if you want to focus more on renewable energy, you want to do on the wind power, for example, you might need this. If you want to go for the flood risk analysis or for plantation agriculture, you might need this or this. Okay, so, or you can combine any of this if you should you wish. I believe there are even more than this. This is the one that I can find. I believe there are more, so you can have a look and explore yourself. Okay, so this is the very basic calculation that I made to calculate rain height. Basically, they call it lapse rate. So how many Celsius you lost when you goes up into the atmosphere. So from there, then I can determine my rain height here. So for example, I have here the temperature slightly lower than 0 degree, and the temperature here slightly higher than 0 degrees. So rain height, the point where the water molecules from the cloud, sorry, the ice particle from the cloud begins to form into rain, is somewhere in the middle here between these two layers. So I use the a very simple calculation just to kind of like calculate the rain height in the middle between this and this. So this and this layer, I know the temperatures, which is slightly below than 0, and here slightly higher than 0, and I also know the height. Remember when I mentioned I need the number 1 and number 5, temperature and height, temperature and height. So once I have this, slot into the formula here for the lapse rate, and voila, I got my rain heights here. Okay, so when I obtain my rain height, I can use it. This is just a calculation to calculate the rain height. I think the examples. So once I achieve my rain height, I can calculate it. For example, from 1980s all the way to, this is 2012. This is my very old research. When I download the data from 1980s to 2012, and then I plotted every year to observe my rain height. So you can see there is a slight increment of rain height, possibly due to climate change. So just imagine in the next 10 years or 20 years down in the line, so will it increase or will it decrease? And if it is increased, how big of a damage will it be for your for your telecommunication infrastructures? Okay, now it may seem small right now, just about 4.9 something to nearly 5 kilometer, the increase of the in terms of rain height. However, just like I mentioned, if it is 10 or 20 years down the line, it might increase way beyond than that. And that at that time, it could be very dangerous. And when you realize it, it may be too late because you already deploy all this expensive network infrastructure, and now you have to deal with the climate change with too much rain, and now we talk about costs. Okay, so that's the idea of it. Okay, so this is the example of using MATLAB codes to read one of the data, NCEP, NCAR. reanalysis data. It's very, very simple MATLAB codes. So I read the file, get the file ID, extract extract the data from the file, and then I configure the latitude and longitude to choose only for Malaysia region. If you want global region, just put, then you don't need this input, okay? And then after that, I begin to specific data, and then display the data, and then I got something that looks like this. So this is the very, what I call it, the basic, or the draft when I try to play around with the data. It is from this code that I can determine whether what's the resolution for the data, what's the latitude and longitude for the data. Is it for temperature? Is it for pressure? Is it for rain? So if the website doesn't tell you what's all those parameters for this data, you can find it yourself using MATLAB or even Python. So this is another more advanced version where from here, it is evolved into here, where now you can include a more advanced features, for example, the coastlines here. So you can see the different continents, and then the titles, the latitude and longitude here. So it's easier to see, okay? So then you can use this coding here. So it is basically the same codes, but I just expand it, improve it, okay? And so that's it. Before we move to the MATLAB to show how it's done, any question from the audience? Okay. What's your preference, Python or MATLAB? This is a very good question. It is a debate even until now, not just among lecturers or engineers, but by everyone, whether MATLAB better or Python better. So MATLAB is basically old school, and Python is the what do you call it, the new kids on the block. So it's very famous, very trendy right now, and it's free compared to MATLAB. MATLAB is quite pricey. Although Python is not 100% free, but at least the fundamental basic features are free. Whereas MATLAB, I think you can sign it for free, but it's 20 hours free per month, and the rest you have to pay, and it's quite expensive in MATLAB. In terms of the industry feedback on Python and MATLAB, when they want to use this to read the data or simulate, they still divided. I thought that they're moving towards Python. Some do move towards Python. Some still stay with MATLAB. So that's why when they did a survey on the what do you call it, important softwares that students must have in order to work in industry, apparently MATLAB and Python is up there, very famous among the industry. So usually when they ask the student, do you know Python? Do you know MATLAB? So to play safe, try to master both, I would say. My preference currently MATLAB, although I'm also moving to Python. The one that I can see that the Python not only is free, but it's in some way more powerful, because you can use I think the so-called GPU if you want to focus more on AI. So go for Python. However, some of its handling of the data, even a simple mathematical operation, very confusing compared to MATLAB, which is a lot easier. So it will be no surprise if you're able to do MATLAB, for example, this much, okay? But when you convert to Python, it will be longer, or a lot longer, even though you want to achieve the same thing. But my recommendation, I know this is hard, but try both, so that you get the experience of using MATLAB and Python, okay? Given the current trajectory of AI development, what are the next challenges to overcome in the meteorological fields? What are the next challenge in the meteorological fields? Because in terms of accuracy, it got that one covered using the AI. I would say maybe the challenge will be to integrate with the other fields, because right now they're trying to integrate with the engineering fields, which is where I'm where I'm in right now with the telecommunications. But for the other fields, it's still very, very fresh. For example, logistic, the shippings, for example. So I'm not sure if they fully utilize the meteorological data. So I think that's the challenges right now, that hopefully they can overcome this, because when we talk about meteorological data, it is usually for agriculture, disasters, fishing. So for all the other heavy industries, including engineering, telecommunication, or even power plants for wind power, so it's still very at early stage. So hopefully they can overcome this. Okay, right. So to explore more and more fields. So these are the current challenges of meteorological fields. Okay, so yes, the one that we've been waiting for, MATLAB. Oops, resume. Okay, hold on. So before that, let me just show to you where to get the data. So if I type NCEP, NCAR reanalysis, for example, and then it will produce here in the Google search. Just click on here, the first link here, NCEP, NCR reanalysis. Okay, there we go. So it shows all this data. Yes, it looks quite terrifying. It looks something like, oh, lots of words here and there. That's fine. That's okay. Lots of these are basically information. Some of you asked about the resolution specification. There we go. So here they provide the information on that. So temporal coverage, how many times it recorded daily? So 4 times daily. Spatial coverage, 2.5, 2.5 degrees. Okay, levels, just now, what I mentioned, 17 pressure levels from near the surface all the way to the top of the atmospheres. Okay, and so the update schedules and the format, which is in NetCDF. This is a very, very famous format used by a lot of meteorologists when they want to store their data. Apparently, this can save lots of space in your hard drive. So that's why they use this one. Okay, so this is the information. The data is somewhere here. So if you look here, see, this is for basically for temperatures in the atmosphere. Temperature, temperature, temperature as well. I'm not sure why they repeat this. Okay, this one, temperature, same thing, but only near the surface level. Okay, temperature, same thing, or temperature in our tropospheres only. Okay, let's have a look. What else do you want? Not sure what's this. I think this is for the wind. Okay. Oh, no, for this solar radiation from the sun. Let's have a look more. Is there more? You can see there's a lot. Just now we see the temperature. Now it's about the pressures, the cloud layer pressures. Okay. This one about rain, precipitation. The word precipitation here refers to rain or water, the accumulation of water, normally because of rain. Okay. And then what else do you have here? So solar radiation, and then the geopotential height. This is the in terms of the height in meters of that layers or levels. So you have different pressure levels. That's true, but what's the height for each of those levels? How many meters? How many kilometers? So this is the one that I use for the rain height. This and the temperatures. Okay, ice concentrations. Most of this I'm not familiar with, but something that you can experiment, something you can have a look. Okay, there are plenty of examples out there on Google that they use MATLAB or Python to read this data. Apparently, when I did my research or read on it, this data here is apparently is quite famous among students and industry to use. Okay, so VU component, all these are for wind vector. So yep, there we go. So lots of stuff if you want to what do you call it, experiment around. I believe they also have the water contents. I think the water vapor, I can't remember.
Hello, Dr. Hafiz. Are you here? Students, are you here?
Yes, doctor. My
Okay.
apologies. My internet disconnected just now.
Oh, same. So maybe we need to wait for Dr. Hafiz. Okay, so I hope you can ask more question, okay, for clarification. Okay, I will check with Dr. Hafiz.
Hello, everyone. Sorry about that. This
Okay, welcome back.
welcome back. Where was I? Is it about the website? I think it's about website. It's okay. I'll share the screen. Hold on, eh? Okay, sorry about that, everyone. Hopefully now you can see the screen. Okay, so this is the website that I was trying to show to you. Hopefully this is the part where I got disconnected. Okay, so when you type NCEP, NCR reanalysis, so it pops up here on Google. Click on it, and then you have this one here. Okay, so some of you asked about the how to know the specification, all the resolutions and other information about the data. So here we go. In terms of temporal coverage, it covers 4 times daily, for example. It also have monthly means and so on and so forth. Spatial coverage, so basically it covers global data from 0 to 360, almost 60 latitude, 90 degrees to another 90 degrees north south latitude. Sorry, this is latitude, this is longitude. and the different levels. Also, it shows NetCDF format. So a lot of meteorologists, they quite prefer this format here because it saves lots of their space when they store the data in their hard drive or server. So this is this information that you can find about the data. If some of the data provider, let's say other than this, they provide free data as well, and you can't find the specification, don't worry. You can use MATLAB or Python to determine the data. Usually they have the same format as well. All meteorologists, they store in the same format. Okay. Now, here is where you can download the data. So you can see here, this is air temperature. So which is temperature that I'll be using for rain height. So there's a lots of parameters here. I can keep scrolling through cloud layer pressures, precipitation. This is for rain, radiations, they have for solar radiations. They have for the height in meters for those atmospheric layers. So this is also the one that I've been using for my rain height. So ice concentration, what else they have? Pressure, so a lots of pressure, a lot, very pressure. So humidity they have, okay. So I think they have the for the wind as well, the wind vectors. So a lots of stuff they have here that dealing with the atmospheres in terms of temperatures, pressures, wind, humidity, water content, rain. So use this however you wish. Whichever research fields that you want to go into, let's say wind power or solar power. For example, just now, if you want to focus on solar power, maybe you can have a look at the solar coverage, solar radiation, for example, or the wind. Look at the wind vectors. If you want to go for agriculture, maybe about rain or humidity. Engineering like telecoms, then maybe also about rain. So lots of stuff that you want to that you can pick and choose which fields or research that you want to do. Okay. MATLAB, there we go. So let's open up MATLAB. So it takes a bit of time with the MATLAB here. Okay, there we go. So invalid function there, never mind. So this is the online MATLAB. So you don't have to download MATLAB right now. You can do it online for free browser. But I'm sure UTM also have free MATLAB software. I'm not sure whether they give it to individually to students or you have to use in the lab. For Utah, we have MATLAB, but installed in the computer labs. Okay, so so far any question? No. All right. So let's move on. So this is the MATLAB file that I'll be talking about. So let's have a look the very basic on how to do this one by one. Okay, so let's say I download this data here. Okay, so I download this data, air temperatures, pressures, normally. Yeah, why not? Let's say if I download this data. Okay, so it displays a lot of this. It can be quite confusing. I think this is actually the same thing. Yeah, it's the same thing, but they rearrange in terms of this style. So you want the air temperature 4 times daily from 1981 to 2010, or you want the current one, which is here. Okay, or you just want to have the monthly air temperature, monthly average or mean. Then you click here. So I think this is for 1 year, or this one also for 1 year. So if I click here, then we'll download this one, for example. Okay. So here you can play around and have a look which data that you want to download and play around. Air usually means air temperature. HGT, height in meters. Omega, this one I'm not sure, probably with the solar radiations. Where is that? This one, wind vector. This and this U and V, wind vectors. It's something like the U direction or V direction for wind. Okay, so lots of stuff. Oh yeah, now remember, I think this is for the rain accumulations. Okay, okay, let's say I have downloaded and then I want to use MATLAB. So here I already download the data and I put in the same directory where my MATLAB code is so that I don't have to declare it or call it upon. So this is the data that I already download, the same data actually. So to read it in MATLAB, first do this. File name, exactly the same name like that. So you have that file name, okay. .nc, this is the netcdf. And then after that here, netcdf open. Now, if you confused or if you stuck something that you can't, you forgot on how to do the, to use certain MATLAB functions, for example, netcdf, don't worry, you can always go to help documentation here. So open. Okay, here, netcdf. This is the one good thing about MATLAB is that they have all the necessary advanced toolboxes, examples that people have been doing for years to achieve the results as compared to Python. But then again, because Python is still new, one day Python will match MATLAB in terms of the number of toolbox and the special function like this. Okay, so there we go, netcdf. So if I click here, netcdf.open, so you have this one as an examples here. Okay, how to use. So they give you the description and then the examples on using the codes here. Now let's have a look at MATLAB again. There we go. Don't worry about this. This means that I'm not going to rewrite the data. I'm just going to download and extract the data. So netcdf open. And so my data is now open. Okay, but now you have another problems. Okay, so my data is now recognized in MATLAB. And the ID is 65536 assigned by MATLAB for this data that I downloaded it. But how am I going to open it? I mean, how many variables does it contain within the data here? Is there any way to determine? Now, you can use this one. This is also a lots of examples in MATLAB help or even Google on how to use this command here. Or basically if you just want to inquire about the data. So this is one examples here. So take this, put it here. Okay, so here they will tell you how many dimension it has, how many variables, how many global attributes, so on and so forth. So basically to get into the data, because if you first time opening the data, you're not too sure where to look for. I mean, okay, yeah, I download the data. So now how I'm going to open it, well, which variable I'm going to choose. I just want the temperature, for example, or I just want the rain. So this is one way to do. First, you inquire about the data. So after that, take a look at this one. Number dimension 5, that's fine. Global attribute 9. This is what you want, the variables. Variables determines that, okay, in your data, this is why lots of meteorologists, they use netcdf because it can slot in a lots of information, not just the raw data, but also the name of the data, the time for the data, latitude, longitude. So some researcher, they need this data to analyze the whole thing. So they store all this in the file. So right now we're going to extract this one by one. So let's have a look. I'm going to play around. This one I put var ID because here it has 7. So basically it is 1 until 7 maximum. Other than that, you get error. So let's say I put here, let's play around first. Let's say 1. Because you're not too sure yet whether it's 1 or 2 or 3, the one that has your data. In this case, I want the temperature data. And then use this netcdf inquire variables. Okay, so the var ID is 1, so they put here is 1, and with the nc ID, which is the ID for the file that you just opened, the netcdf file. So if I put like this, press enter, so it should display, there we go, var name. Focus on the var name here, latitude. All right, so the first var ID here refers to latitude. Okay, that's fine. Okay, so let's try var ID 2. What will it give me? Longitude. Okay, good. Now we're getting somewhere. Okay, so var ID 3. Time. Okay, so it will, this section is about time only. Okay, that's very good, very good. I think we're close. Number 4. Climatology boundaries. I'm not too sure what's that, but that's fine. Okay, sometimes we can always try and errors until we find what we want. All right, now var ID 5. Let's have a look. Air, or in Malay words, water. Nah, it's air. Okay, so this is what we want: air temperatures. So once we got this, then we use this one. Now we're going to tell MATLAB, okay, I got it. Now I don't want time. I don't want all the other stuff. I just want the raw temperature. So that's why I put here number 5, or var ID if you want to put it, because you already declared here 5. Okay, so put it like this, and then it will display, it will give you this one, global temperature, global map. This is what I define myself. You can name it however you wish. For example, KKXSWW omega whatever equal to this, it still you get the same thing. Okay, you get the results. This is you, the one who declare here. Use your creativity. So here I get 144 times 73. This is the how big it is. Longitude, latitude, 17. If you remember, this is the pressure level, 17. So it has 70 pressure levels, 12 months. So this is for 1 year. So we can have a look monthly, on monthly basis. All right. So let's have a look. So we got all that. So now I just want to display the data, because that's what you want in the end. We want to look at the data. How does it look like? So, yep, let's display the data. Don't worry about this. This is just for the reference if I want to view only in Malaysia. Okay. P color. So P color, okay, I haven't put this one yet. Okay, there we go. Now, P color is one of the MATLAB function to display the data. So if you put P color, then it will display the data. There we go. That's how the data looks like. Don't worry about the warning. I don't know why. When I use MATLAB online, it always has this warning. But my installed MATLAB version is fine. Okay, so this is how the data looks like. Raw data. Now, it looks weird because it's kind of like the upside down, because this is your North Pole. This is your South Pole, equator around here. If you see carefully, hold on, can I zoom in here? How to, oh my God, hold on. Zoom. This is the thing about MATLAB online, so it's quite confusing. But if you able to zoom in, you can see this is Australia. There, somewhere there is South America, something like that. So Malaysia is somewhere, I think, somewhere in the middle here. But it's very hard to see from here, isn't it? From the raw pictures. And plus it's upside down. So this is the, what do you call it? The draft version. And now we move to the more advanced versions. Is it here? Yes, here. This is the more advanced versions. Okay, so Every time if you use MATLAB, you can always clear all to start fresh, reset everything. Okay, now we move to the a different codes or more advanced that perform the same thing but give a more information. So it's basically the same thing, but now we because we already know our variable ID, which is 5, to extract the air and all the other stuff. So I use this one. Okay, this one you can have a look later how to perform, and then after that I'll show it to you. Okay, let's run the data. So now it looks, yeah, there we go. Now that looks a lot better with all the coastlines. It looks cleaner. So the blue color here refers to colder temperature, red hotter temperatures, okay, green somewhere in the middle. I'm not sure why this one's actually warmer than this, and it's quite worrying, isn't it? But never mind. Climate change, I suppose. Okay, so this is the more improved version. So in the improved versions, I have to do a bit of tweaking. For example, rearrange this data because somehow when I open the raw version, this and this is upside down. So I have to rearrange them. And then what else? I use the interpolation function to make it a smoother transitions here from colors to colors, color jet. So that's why you have these beautiful colors here. And then what else? X label, longitude, Y label, latitudes, title here. Okay. And then for this coastline, simple here, load coastlines. And then the coastline here, I need to kind of like tell to MATLAB, okay, the coastline should be cover the longitude from 0 to 360 and latitude from 0 to 180, something like that. And then put it here. Because the problems with the data doesn't have negative values for latitude and longitude, but for coastline, it has the negative values. So for example, the latitude here from 0 to 180, but for the coastline, minus 90 to 90. So I have to convert all of them to positive values. That's why I have to put this one here. So now it matched. And when it's overlapped, it looks something like this. Okay. K here means is the black color lines. So if I put BL, that's blue. So let's have a look. Ta-da! Now it's blue color. So this is the beauty things about MATLAB or even Python. You can go ahead and play around, familiar yourself. Eventually, you'll be an expert in it, way even more than me. Okay. Right. So this is the step 2, and I'm pretty sure you want to have a look more. Perhaps some animations, if possible. Sure thing. I got you covered. So let's have a look for the animation style. Okay, this is for the animation. The animation, because if you notice in our data, we have just now for 1 year. So we have 12 months in 1 year. So it is monthly. That's why the data here called air temperature monthly here. LTM, I'm not sure what's this. Okay, but never mind. So it's the same thing, but with the additions of this one here. Basically looping to create a loop so that the data can read one by one from January to December's. Okay, so let's have a look. There. Error. I got errors here. Unrecognized function coast latitude. Where is it? 936. Okay. So maybe I have to borrow something from here. Okay. So this one here. So yeah, minor technical issue. Let's have a look. Oh my god, I don't know what happened. It was just now flawlessly, or maybe I forgot to save or somehow. But yeah, maybe it's something that you can experiment around. So this is what happens when yearly from January to December. So let's run again. Let's have a look. Okay, so eventually the North Pole become warmer and South Pole become colder as it moved from January to December. And then again, north cold, colder temperature back at north, and then warmer temperature at south. Okay, so this is the thing that you can play around, and you can basically what do you call it? Apply it in your FYP or IDP, or even when you work, because like I mentioned, just currently DNB and Cellcom Digi is looking data scientists who knows how to experiment with the meteorological data for them to analyze the potential locations for their site deployment, because they don't want the site to be at risk due to floods or heavy rainfall that can affect their signals. So that's one application. And there are many things. Salary, 5K. Sorry, not 5K, 5 digits. And that's in Malaysia. Others for overseas probably pay a lot more. We never know. Okay, so any questions? Oh, a new question. Hold on, I missed some of this. What are the advantages of using MATLAB for meteorological data analysis compared to other software? A very good question. MATLAB, the advantage for MATLAB is because they have those toolboxes to read the meteorological data, which means that MATLAB, they already have the tailored functions to open and to read and to display meteorological data. Other softwares, for example, Python, they don't have it. So you have to download external toolbox, I guess, or some people that already created the library for it. So you have to download it and then use in Python. Whereas MATLAB, they already have that toolbox. So that's why the some meteorological people, they prefer to use MATLAB. However, with the trend, so some people, they can what do you call it, switch to Python. That's not a problem too, because now more and more people developing new toolboxes or new libraries for Python to read meteorological data. So the difference is that MATLAB, they are already established, but they also kind of like the old players, the old guards, whereas Python is the new kid on the block, still fresh, still young, a bit naive on the meteorological data, but they are learning, and they are learning very fast. So try to learn both of these, okay? Usually it's not much of a difference, the how to read the data in MATLAB and Python. Once you master these two, you can see, hey, it's not that different. It's quite similar actually. So you get the hang, the flow between the two softwares. Okay. NVIDIA recent keynote in Taiwan, they used digital twin to simulate Earth. Okay, okay. Whatever, including duration, are the two usually still needed? Okay, okay. Recent keynote. I believe they used probably the supercomputer, because Taiwan is known to have a powerful supercomputer server. So and one of the applications from the supercomputer is basically to simulate this, the weather patterns, for example, because weather, they need a lots of input parameters. So a supercomputer can perform the job. In fact, the one that provided by NASA, the one that I showed you the data, that one also use supercomputer in the US to integrate all the data. Now, basically, I think what it does is that it simulates this thing to predict disaster, including duration, damage level. It could be. Yeah, this is something that you can probably do a research as well with the NVIDIA if you get the chance, and then try to compare with your research whether it's similar or maybe the one in Taiwan better, or are they something like the focus too much on the Taiwan, or it can be applied globally? Will it be limitation in terms of hardware, for example, the processing speed, or because like the simple data that we have, you don't need supercomputer. You can just run in your laptop or in any PC, for example. Whereas in Taiwan, I'm pretty sure they're more advanced, so that's why they have the supercomputer to run this simulation. So yeah, maybe in terms of the cost benefit. So you probably can run cheaper versions using the free software, available software to make a simpler prediction. Because sometimes engineering is about achieving the output that we want at the right cost, at the right price, and make our boss happy. Okay, but it's a good question. This is something that you can compare to, or what they call it, literature reviews, compare with their research, okay, and find the pros and cons. Okay, so any questions so far? Good, bad, inspired, or suddenly you have an idea for your FYP or any other research? Remember, the current trend right now is climate change, natural disasters. So this is something that you can use the data for. Who knows? You might go on work later on, graduate, and you work in the industry that require this thing, and you got the idea. Hey, I know this data, but probably I can use it and to create a simple predictions. Okay, make your boss happy, get 5K, sorry, 5-digit salary. All right. So, any more question? Okay. So I'm quite intrigued as well about the this one from Justin about the digital twins. So it does seems very promising. Although I think in terms of the resource that needed to run it may be quite extensive because it may use supercomputer. But still, regardless, so if you want a greater details, then probably this is it. But if you want just a simpler solutions or a very cheap, simple but very effective solution, then maybe use this data here. Okay, but I bet usually this meteorological data, they usually collaborate each other, even Malaysia. So Taiwan, Malaysia, everyone, we usually contribute the data, including the US. So and then they create this one big giant global data, and the one that you've seen just now, that one also created from the supercomputers. Okay. All right. So anything else that you would like to ask about MATLAB or Python, about the data itself, or is it okay? Everything okay? I think everyone's fine right now. I think or should I add more?
Okay, I think student already understand about your talk and also your slides. So I think no question from student So if no question, I want to close the Q&A. Okay. Right. So thank you to Dr. Hafiz, okay, for delivering a special talk, okay, entitled training on meteorological data, right? Okay, using MATLAB. So I hope student can benefit from this talk. Okay, and maybe we can take the photo with Dr. Hafiz. Okay, so can you open your camera? Maybe Andre, can you take the photo, Andre? So after this, I will share the attendance. I forgot to share the attendance. Okay, Andre. Okay. So please print screen. Okay, smile. Okay, wait. Okay. All pages. Okay, smile. Okay, done. Next page. Okay, next page. Okay, I'm not sure how they distribute the uh, photo for every page. So make sure you always smile. Okay, thank you. Okay, so thank you everyone. So please scan your attendance first before you leave uh, this session. And thank you to Dr. Hafiz. And I hope we can invite Dr. Hafiz more after this. Okay, so thank you.
Thank you all for having me for today's session. So I hope you all enjoy the session today.
Thank you, Dr. Hafiz.
Thank you, Dr. Hafiz.
All right. Thank you all again.
Thank you, Dr. Hafiz.